Okay guys, so here we are for the running test review again. First set asks you to classify these numbers. So classifying numbers is not terribly difficult, but really you just kind of have to memorize these numeric rules. So for classifying, the first type that we have would be either rational or irrational. So irrational numbers are numbers like pi or hard square roots that don't have an easy answer. So square roots that go on forever. So the only irrational number here is actually number 3, 2 pi. So we would call this one irrational. Everything else is at least a rational number. So if it's a decimal or a fraction, it's automatically a rational number as long as it doesn't keep going forever. If it repeats, it's okay. So as in number 5 is a repeating decimal. This is a rational number. And number 4 is also a decimal, so that's also a rational number. The other two are regular numbers, and if it's just a normal number, like the number 12, then that number is a natural number. That's the most specific it gets. And negative 40, well, we have natural numbers, but those are positive numbers. And if it's 0, what we call a whole number. And once you get into the negatives, then the most specific classification you can get is an integer. Because we use I for irrational, integer is a z. Okay, these are estimating square roots. Estimating means you want to give a decimal answer, but you're not going to be allowed to use a calculator to do this. So for number 6, we want to do the square root of 48. We know the square root of 49 is 7. And the next lowest perfect square is 36, which would be 6. So what we're saying is that our answer to this will be somewhere in between 6 and 7. So obviously it's a lot closer to 7 than it is to 6. It's only one number off. So we call this one something like 6.5. So likewise, the number 7, 8, and 9, you're going to approach it the same way. What two numbers would it be between? Well, this one, the square root of 100 is 10. Well, this one is just short of that, so this one must be just less than 10, so square root of 99 must be just about 9.9. Square root of 39, here we are again, just a little bit more than 36, something like 6.2. And finally, square root of 53, that's between 49 and 64. It's closer to 49, so we must know it's less than 7.5, something like 7.2. Okay, the directions for these problems say simplify. That takes us away from leaving decimal answers into giving the most simplified square root answer. So this is the one where you're going to need those perfect squares. So it's usually a good idea to make a list of them very quickly. And so 75, we're looking for the biggest perfect square that divides evenly into 75. That happens to be 25. So this is 25, and it will be times 3 to give us 75. So we write it as the square root of 25 times the square root of 3. And the square root of 25 is 5. The square root of 3 left over. That's our final answer. So when a square root is already put together, the plan is to separate it, like in number 10. In number 11, the square root is separated, so generally the strategy is to try to put it back together. So 2 times 32 is 64, and in this case, the square root of 64 is an easy one. 6, 8. In number 12, we see that now we're dealing with fractions instead. One of the properties for fractions is if you have one that is put together like this, usually the strategy is to separate it into 2, like this one. And when you do that, you can see the square root of 81 is 9, and the square root of 16 is 4. Similarly over here, it's the exact opposite. So just like we did with number 10 and 11, kind of the reverse procedure, this one is already separated into two. The plan would be to make it into one. And because when you do that, 128 over 2 is actually 64, so we end up with 8 as an answer 1. Okay, this time we're on to the simplifying expression. So usually you see a lot of distributing, and this one is no exception. We're going to take this 5 and multiply it by each thing in parentheses. And out here, we have a 6, but this negative goes with it. So it's actually negative 6 times these two things. So we end up with negative 12x and negative 18y. And since there's no more multiplying or anything to be done, it's only combining like terms. So as you can see, we have an x here and an x here. We put them together, 5 and negative 12 gives us negative 7x. And we have a y here and a negative 18y here. So 5y and negative 18 is negative 13y. And since we can't combine any more terms, we are done. So the same idea holds true for this problem. We're again looking to simplify and combine like terms. If you notice there's a negative sign right here, we can think of that as a negative 1 times all of this stuff. So we have a 3x, and we have negative 1 times 2y, that's negative 2y. Negative 1 times negative 4 is positive 4x. And then the rest of this problem. So now it's again combining like terms. You can see we have some x terms, but this x squared term out here is different. You can't combine that with a regular x term, so that one's going to have to stay by itself. So let's put the x's together. Usually the idea is to write bigger exponents first. So these x squared and y squared terms should go first. So let's rewrite them because they actually don't combine with anything. Now the x's combine to give us 7x because we have a positive 3 and a positive 4. And the y's are negative 2 and negative 5. And makes us negative 7y. And once again, because we have no more like terms, this whole thing is our final solution. So sometimes they don't go that small, but that's all you can do. Okay, last thing for this page is to write an expression for a word problem. So writing an expression is not usually too bad. We basically want to say we have a 300-gallon water tank and it's losing 4 gallons of chocolate every hour. Write an expression for the number of gallons remaining after 8 hours when the tank is full from the beginning. So basically what we're saying is we're starting out with a 300-gallon tank, and let's say that, for example, if we waited for 4 hours, we know we're losing 4 gallons per hour. Well, that would be minus 16. But what I'm saying to myself is I get to 16 by taking 4 times 4 and then subtracting it from the 300. And I get my answer of 284. So that's kind of like a hypothetical problem, but I want to write it for any number of hours, 8. So instead of putting the 4 for my hypothetical number of hours, I'm just going to put an 8 there instead, so it can be anything I want. So basically my problem becomes 300 minus 4 8. And since it wants to know how many gallons are left after that, you could say this is equal to G for the number of gallons. And that would be your expression.